See beni hasret hasret stasera a trovaga mi mai ma caso che la sale sale
Check, check. Okay. Good evening. Can you hear me? Can you hear me? Guys, can you hear me? Yes. Okay, and board is clear, right? Can you send me message? Is it clear, right? Everything okay? Good. Thank you. Okay. Good evening, all. Last week we discussed the basic part of the measurement lesson, our first physics lesson. The basic part. What we discussed last week? Last week we discussed about what's the meaning of. That's a summary of the last week class. We discussed what's the meaning of the measurement. No, what's the meaning of the measurement? What's the meaning of the measurement? What's the meaning of the measurement? Okay, what's the meaning of the measurement? Giving a numerical value to any physical quantity. As example, if you got kilogram, mass is a physical quantity. Sorry, mass is a physical quantity. Mass is a physical quantity. If I told numerical value with unit 5 kilogram, it's a measurement. Giving a numerical value for any physical quantity, right? Giving a numerical value for any physical quantity. That's the meaning of measurement. Okay, as second topic, last week we discussed about, do you remember what's the second topic? Before that, Khalindu and Shevan, did you got the tute? Tute Sambuna? No. Oh, I think, මෙතන මට ගොඩක් අය කිව්වා හම්බුණා කියලා සමහර අයට හම්බෙලා නැහැ. දෙතුන් දිනකට හම්බෙලා නැහැ. The problem, the transport limitation. Oh, the transport limitation is a problem. I have posted last week Friday. සමහර අයට හම්බෙලා. Yes. 5 students got tute. Shivan, no. Oh, yeah, that's the problem. Okay, you can check. Yeah, tomorrow you can check in your post office. Normally, I am sending post through post office, our normal government postal service. The problem now it's more than 1 week. Then සාමාන්‍යයෙන් අපි before this crisis, normally the time for any area it is only 3 to maximum 4 days. Maximum 4 days. But due to this crisis, you know, the government, all government services now they have limit the transportation, including postal services. That's the problem. Okay, however, for today lesson, I will now you all have PDF, right? You all have PDF. Tomorrow definitely you will receive definitely tomorrow. If not, you can check your post office. අනිවාර්යෙන් හෙට හම්බේ. The problem, again, another problem, the Wednesday is completely government sector not working. Yeah, that's problem. And Saturday, Sunday, now holidays are more than working days, no? That's the problem. Hard. Okay, no problem. I will give you important points to note down as a short note. Then you can note down in your written book. written book. If you don't have tute, tute. If you have already tute, you can use that and note down important things in tute. Okay, no issue. Today I will explain for both students, and I will explain how to write down and how to complete your tute, everything today. From next week, definitely you will all receive tute, and we can continue as usual. Har. Okay. Har. Okay, last week we discussed about measurements, and as second topic we discussed about prefixes. No, do you remember? Prefixes. Okay, what's the meaning of prefixes? If any measurements too small or too large, it's a group of symbols. The prefixes are group of symbols that we can express these measurements, too small or too large measurements, in easy understandable way. As example, if you got kilo, mega, peta, tera, peta, giga, okay, they are the prefixes. If you got very small measurement, what are the examples? Deci, centi, milli, micro, nano. Okay, they are the examples for prefixes. It's a set of symbols that we can use to express too small or too large measurement in understandable way. Lazy and we can explain, right? We can express. Okay, next one. I told when we take measurement, the most important thing, the accuracy. The accuracy is the most important thing. When you take any measurement, if it is not accurate, I told the measurement is useless. We can't get the actual exact purpose of this measurement, right? Okay, the accuracy is the most important factor when you take any measurements. Okay, what are the factors need to be considered when you take any measurement to keep the accuracy? What are the factors? Last week we discussed. One of the factors. Guys, what are the factors? Okay, let's revise again. Last week we discussed one of the factors. I explained 5 factors, no? 5 or 6 factors. Yeah, 6 factors. Okay, what's the first one? Select suitable measuring instrument, no? Select suitable measuring instrument according to the measurement. What's the second one? Yeah, keep clean and clear. The object and instrument both keep clean and clear without any impurities. Very good. Without any impurities. What else? Keep clean and clear. What else? Clean and clear. What else? Yes, very good. We have to avoid take measurements unstable object, like moving objects. Always the object should be fixed. Always we need to get measurements of fixed object to get accurate measurements. Next, Yeah, you can send me answers to chat. You can type in your chat box. Yeah, what's the next factor? Yes, very good. Eye level. We have take measurements at eye level. Looking, reading need to be take in eye level, at eye level. Okay, eye level. Okay, before that I explain another factor. Then padang karandone. A level is not like O level. You can't. Every day you have to work at least 1 hour per subject. Hari. What's the next factor? Next. Very good. Take measurements at room temperature. Take measurement at room temperature. Yes, very good, very good, very good. We have to avoid apply additional pressure on the object, right? Otherwise, it can be change the shape. Change the shape. Okay, we have to avoid apply. I told the measurement taking is very sensitive process. Very sensitive process. If you need more accurate measurements, we have to get very carefully. Measurement taking very carefully. Hurry. Okay, that's the last week lesson. Final part of last week lesson, I explained about least count, right? Least count. Least count of measuring instruments. What's the meaning of the least count? What's the meaning of the least count? Guys, what's the meaning of the least count? The definition? Yeah, the least count is the smallest or minimum measurement of any instruments that can be accurately obtained. The minimum measurements of any instrument that can be accurately measured by any measuring instrument, right? Accurately can be measured. Okay, I told if you got meter ruler, do you remember what is a least count? Meter ruler. What's the least count? Last week we discussed. Meter ruler. 1 millimeter. Very good. Yeah, all you can send me answers. Then it is easy to keep it as a discussion, right? Then it is not boring. Hurry. Meter ruler. 1 millimeter. If you got vernier caliper, last week I explained. Vernier caliper. Vernier caliper. What's the least count? Very good. 0.1 millimeter. That means 1 millimeter we can divide into 10 parts. Yes, 1 millimeter we can divide into 10 parts and get the value. If you got micrometer screw gauge, micrometer screw gauge, 0.01, right? 0.01, that I told 1 millimeter we can classify it into 100. We can divide into 100 parts. That much sensitive. That much sensitive. If you got triple beam balance, 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 triple beam balance 0.1 gram. Okay, now you can see instrument to instrument what happened, this least count is vary, right? Instrument to instrument, actually instrument has their own least count. Instrument to instrument, instrument type to instrument type, the least count will be changing, right? The least count will be changing. Very good. If you got stopwatch, digital stopwatch, what's the least count? Digital stopwatch, I told 0.01 seconds. Okay, now you can see instrument to instrument, the minimum measurement will be vary. It is changing. Instrument to instrument, the minimum, the least count is changing. That's only we discussed last day. This is summary of last week lesson. Okay, today we are going to discuss about measuring instruments. Hari, I'll open the tute in our board. Then if you don't worry about, if you don't have tute, without any issue, you can understand. Hari. Okay, this is a least count of the measuring instrument. Hari. The least count of measuring instrument. Okay. Action. Okay, do you have any doubt up to now? Up to this level? Do you have any doubt? Do you have any doubt? No, up to now, okay, right? Up to now, okay. Okay, actually, our today lesson, we are going to start about measuring instruments. Now, last week, we only discussed about background. What's the meaning of least count? What's the meaning of measurements? What's the meaning of prefixes? It's just only background. Okay, today we are going to start measuring instruments. Hari, in your notebook, please note down the summary of the remain part of the lesson. In this, from this point, I am going to start measuring instruments. Hari, අපි measuring instrument තමයි start කරන්න යන්නේ. Measuring instruments. Measuring instruments. We are going to start measuring instruments. Okay, measuring instruments, in this lesson, we can divide into three main categories. We can divide into three main categories. The first one, length measuring instrument. Length measuring instrument. Length measuring instrument. The second one is the mass measuring instrument. Mass measuring instruments. Mass measuring instruments. The final one is a time measuring instrument. Time measuring instrument. Time measuring instrument. Okay, in this lesson, different types of but in this lesson, we only discussing about length measuring instruments and mass measuring instruments and time measuring instruments. Okay, in this lesson, as length measuring instruments, we discussed, we will discuss four main instruments. The first one, meter ruler. Meter ruler. Second one, Vernier caliper. Vernier caliper. Third one, micrometer screw gauge. Micrometer screw gauge. Screw gauge. Micrometer screw gauge. Fourth one, traveling microscope. Traveling microscope. Why this fourth instrument we called as traveling microscope? What's the reason? A traveling microscope, is it moving? Is it portable? But Vernier caliper also portable. We're not going to call Vernier caliper as traveling Vernier caliper. Then why we call the traveling microscope? Is it it is a microscope? Then it is it length measuring instrument or it's magnified instrument? Yeah, we can learn. Traveling microscope. Traveling microscope. Make up normally microscope. Yeah, you have problems. No? You should have problem. It's a microscope or length measuring instruments. Okay, it is actually the traveling microscope is a microscope type length measuring instrument. Microscope type length measuring instrument. Okay, in mass measuring instruments, we discussing about two main instruments only. The first one, triple beam balance. Triple beam balance. Triple beam balance. The second one, electronic balance. Electronic balance. Triple beam balance and electronic balance. Under time measuring instruments, we discussing about we will discuss two main instruments: digital stopwatch and digital stopwatch. Digital stopwatch. Second one, analog stopwatch. Analog stopwatch. Analog stopwatch. Okay. First of all, you can note down this summary of the lesson. If we discussed all, if you know everything about this all instrument, this lesson will be completed. That's the target of this lesson, to discuss and understand about this each and every instrument, measuring instruments. Okay. First note down this summary. Okay. Today we are going to start measuring instruments. Measuring instruments. Hi. Note down first. Complete. Is it complete? Kalidu, complete. Okay. Actually, last week we discussed about the background of lesson. It is not the lesson. Now we are going to start our actual lesson, measurement lesson. we are going to start measuring instruments. In measuring instrument part, we are discussing three main instrument types: length measuring instrument, mass measuring instruments, and time measuring instrument. Okay, now we are going to start our first measuring instrument type, length measuring instrument. Length measuring instrument. Okay, under length measuring instrument, our first length measuring instrument, I am going to write in short form. Length measuring instrument, the first instrument, meter ruler. No? Our first instrument, meter ruler. Okay, now you already know what is the least count of the meter ruler. Meter ruler. What's the least count? What's the smallest measurement? Can we get accurate? Meter ruler. What's the least count? I need answer from all among that. What's the least count? What's the least count? 1 millimeter. Very good. 1 millimeter is the least count. Least count equal 1 millimeter. Hurry. 1 millimeter is the smallest measure of meter rule. Hurry. Now, can I get 0.8 millimeter? Is it possible? 0.8 millimeter can I get by meter ruler? No. Less than 1 millimeter. That means less than least count, we can't get any measurement less than least count. Less than least count, we can't get any measurement. Therefore, 0.1 or 0.8 or any 0 point value we can't get. Then can I get using meter ruler? Can I get 8.4 millimeter? Is it possible? I need answer. If not, it will be boring. Using meter ruler, can I measure 8.4 millimeter? Yes or no? Hasandu? Yes or no? Is it possible to get 8.4 millimeter using meter ruler? Okay, 3 answers. Yes. Others, what do you think? Yes or no? I'm asking. Temin or Tumin? Metsar. Yeah, all of you answer yes, possible. But you all are wrong. But you all are wrong. Why? The least count of the meter ruler 1 millimeter. Then can I get 8.4 millimeter? 8 millimeter, okay. Then how to get 0.4? This 0.4 එක කොහොමද අපි ගන්න? How to get this decimal point using meter ruler? Take, you don't know about meter ruler, take your ruler. ඔයාලගේ ruler එක ගන්න. Can I get accurately 8.4 millimeter using your ruler? No, 8 millimeters you can get. You can measure 8 millimeters. 8 millimeters, okay. But can you get 8.4? How you get accurately? No. Understood, Kalindu? No, it is not possible. 8 millimeter, okay. The least count is a minimum possible value. ඒ වුණා කියලා අපිට ඊට වඩා වැඩි ඕන එකක් ගන්න බෑ. That has some limitations. We can't get using meter ruler, we can't get millimeter decimal point values. We can't get decimal point millimeter values. As example, okay, now tell me, 12 millimeter, is it possible using meter ruler? Yes, very good. That's okay, it's possible. This one, 15.2 millimeter, is it possible? 15.2 millimeter. No, we can't. How we get 0.2? How we get 0.2? You don't have any method to get 0.2. Okay, therefore, using meter ruler, we can't get millimeter decimal point values. We can get only millimeter. The millimeter, 1 millimeter is the least count. Therefore, we can get only whole millimeter numbers. We can get 1 millimeter, again 2 millimeter, 3 millimeter, up to 1000 millimeter. 1000 or more than 1000 we can get. Now we can only get millimeter whole number. Hurry. Can I get using meter ruler? Can I get 4.3 centimeter? Is it possible using meter ruler? I need the answer from all. Among that, 4.3 centimeter. Yes or no? .3 centimeter. Yes or no? Hamon. Hesandu. Is it possible? No, it is possible. Then හිතන්න ඕනේ හරියට. You have to think carefully. Only 2 students correct. 4.3 centimeters mean 43 millimeters. 4.3 centimeters mean what? How many millimeters? 43 millimeters. 43 millimeter, no in decimal points, in millimeters. Then we can get. Understood, Senon? Okay, what you need to remember, meter ruler, it is very simple. The least count is, what is the least count of the meter ruler? 1 millimeter. We can only get millimeter whole numbers. The millimeters වලින් whole numbers විතරයි. Millimeter whole numbers. Then when you check the possibility, you have to convert always into millimeters. Don't think in centimeters. If anywhere giving centimeter value, you can convert that, no? You can convert this measurement into millimeter. How to centimeter convert into millimeter? Multiply by 1000. Sorry, centimeter convert into millimeter, multiply by 10. Multiply by 10. Because for 1 centimeter, how many millimeters? 10 millimeters. 10 millimeters. Convert kalla balan. This one, is it possible 0.8 centimeter? Is it possible or not? Yes or no? 0.8 centimeters. Yes or no? Harindu? Yeah, very good. Now you are in the track. 0.8 centimeters mean how many millimeters? Say no. 8 millimeters. 8 millimeters, no problem. We can measure using meter ruler. Hari, මේකත් කියන්න. Final bar. 2.8 82 centimeter. Is it possible to measure by meter ruler? Yes, very, very good. We can't measure. Yes, very good, very good. All are correct. All are correct. Why we can't? If you convert into millimeter, it has decimal point, no? 28.2 millimeters. It has decimal point, therefore we can't. Hari, final one. තව එකක් කරමු. This one. This one. .42 meters. Is it possible to measure? Now you all in track. Hari, තේරලා තියෙන නේද? Yes, very good. 8.42 meters mean how many millimeters? How many millimeters? 842. Sorry, 8,420 millimeters. Because per 1 meter, 1000 millimeters, no? 1000 millimeters, 1000 millimeters, 8,420 millimeters we can measure because it's a whole number. අපිට මොකක්ද condition එක? We can't get millimeter decimal values. Centimeter, meter, okay. Millimeter decimal value we can't get by meter ruler because the least count is 1 millimeter. The least count is 1 millimeter. Okay, that's all about meter ruler. You don't need any note or anything for meter ruler. It's just a simple instrument. Just some simple measuring instrument. Okay, let's move into our very important instrument today. Actually, this is our today lesson. Let's move into our Vernier caliper. Vernier caliper. Vernier caliper. Hari. කවුද දැකලා තියෙන්නේ? Anyone have seen a Vernier caliper and use this? How they use කරලා තියෙන්නේ? Raise hand if anyone used Vernier caliper before. No anyone? No anyone used before? Okay, actually this is a new instrument for you. It has 2 linear scale. That's the difference. It has 2 linear scale. Okay, let's start very basic level and complete everything about Vernier caliper. That is a very new instrument for you. That's very new instrument for you. Okay. If you have tute, come to page number 2. If you don't have tute, you can open your PDF or you can, this is a note. Okay. First of all, we are going to discuss what is the principle of Vernier caliper. Or what's the principle of Vernier scale? Hari. The principle. Principle means the concept, basic concept. Okay, principle. Yes, what is the first thing? Okay. Principle of Vernier caliper. Hari. Principle of Vernier caliper. I will explain in very simple way. Try to understand 100% idea. Then you can get full idea about Vernier caliper and easily answer for any question and easily read any measurement using Vernier caliper. Hari. Normally, Vernier caliper has Vernier caliper has two scales, two linear scales. Vernier caliper has two linear scale like this. Vernier caliper has two linear scale like this. This is the first scale, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 millimeters and 1 centimeter, right? It is 1 centimeter mark or 10 millimeter mark. 11, 12, 13, 14, 15, and it is continue, this scale continue up to 15 centimeter or 150 millimeter. 150 millimeter or 15 centimeter. Normally, how about the size of 15 centimeter? Short rule ek 15 centimeter rule ek gun. It is same like your ruler. Your ruler that we called as a main scale. That we called as a main scale of the vernier caliper. Main scale. Main scale. Main scale. Main scale. It is same as your ruler. Ruler just scale. With millimeter scale. With millimeter scale. Millimeter and centimeter scale. This is a main scale. And the vernier caliper has another linear scale. Another linear scale. What is the least count of this type scale? What is the least count? Only 1 millimeter, no? Then making mind the least count, the minimum reading is 1 millimeter. But what is the vernier caliper target? What's the target? Get less than 1 millimeter reading. Apita 1 millimeter instruments on, and we can get using your meter ruler or your ruler, small ruler. Okay, what is our target of this vernier caliper? To get value less than 1 millimeter. That's the target. Okay, then making minimum reading 1 millimeter that we discussed previous. Okay, now as a concept, now I will draw some additional part of main scale. 15, 16, 17, 18, 19, 20. It is continue up to 15 centimeter or 150 millimeters. I have only got 2 centimeter part. 2 centimeter part or 2 millimeter. Zoom okay, now this is a 0 of the main scale and this is the 0 of the vernier scale. That's another scale. May balanne එක තියෙන විදිය 0 0 1 2 3 4 5 6 7 8 9 10. What happened? Some amount of parts on main scale, may balan meyalage parts amount ekak, normally it is 9 millimeter. For this instrument, 9 millimeter, divide into some particular identical parts. Identical parts will divide karna. For this instrument, it is 10. 9 millimeter divide into 10 identical parts. 9 millimeter divided into 10 identical parts. Okay, that is actually basic concept. To what is the target of this instrument? To get less than 1 millimeter reading. To get less than 1 millimeter reading. This is a basic concept. Some part of main scale, some part of main scale, some amount of divisions on main scale divide into identical parts, particular number of identical parts using another linear scale. That second linear scale we called as vernier scale. Vernier scale. Second linear scale we called as Vernier scale. Now I will show you the instrument and explain what's the meaning of main scale and Vernier scale. Then you can get the full idea. බලන්න. හොඳට අහගෙන ඉන්න ඕනේ අද. Okay. Can you see my screen? My shared screen with cursor. Please send me message. Yeah. Okay. Now understand. හොඳට බලන්න. Wait. Today lesson very important. Hurry. Because first of all you need to understand the basic concept of this vernier caliper. Then then we can discuss any type of calculation and reading measurements using vernier caliper. Hurry. I told the vernier caliper has two scales. This is the main scale. This one is the main scale. Main scale, I told it's 0, 1, 2, 3, 4, 5. 5 means 0.5 centimeters. 6, 7, 8, 9, 10 mean 1 centimeter. 11, 12, 50, 1.5 mean 15. It's continue up to 15 centimeters. But for this instrument, I have given only 5 for you understand. I have to make a 15 වෙනකන් යනවා. It's continue up to main scale, continue up to 15 centimeters or 150 millimeters. Okay, now I told the vernier caliper has another scale, another linear scale with only 10 parts. It no more than 10 parts, it's only 10 parts. බලන්න, this is the main scale 0 and this is the vernier scale 0. Now, if you got this up to this level, it is only 9 millimeters, right? 5, 6, 7, 8, 9. 9 millimeters on main scale. That means some amount of parts on main scale, some amount of segment on main scale divided into 10 identical parts using vernier caliper. Using vernier scale. I got the concept. Okay, calculations I will explain. First, you need to understand this basic concept. Some amount of parts on main scale divide into some particular identical parts. නේද? මේ ගාන වෙනස් වෙන්න පුළුවන්. This dividing part can be changed. This dividing part can be changed. Okay. Can you send me message if you got this idea? Or do you have any doubt? Please ask me. First, only understand this instrument. 9 millimeter on main scale. See, 9 millimeter up to this point, 9 millimeters. 9 millimeters on main scale divided into 10 identical parts using vernier scale. අනේක තේරුම් ගත්තා නම් හරි. If you understand this point, you can understand other instrument as well. Okay, others? I got? වැඩ තේරුණා? Okay, and the second point, the Vernier scale, we can move along the main scale. See, Vernier scale, we can move along the Vernier's main scale. Vernier scale, we can move like this. Hi. Now, again, come to lesson. Hi. Now, I will show you actual instrument. This is a virtual one. Okay, this is the actual Vernier caliper. But the problem, this is a modern one, okay, digital one. Don't think about that. Hurry. Okay, see, this is a Vernier scale. මෙතන මේක display එකක් තිබ්බට this is a digital one. But in our lesson, we discussing about manual one. I will explain the difference. This is a modern one actually. This is a modern one. Hurry. This is a main scale now. Wait. This is a main scale. You can see it's continue up to 150 millimeters. 150 millimeters. And the Vernier scale moving along the main scale, right? This is a main scale. This is a main scale. The Vernier scale moving, right? The Vernier scale, we can move along the main scale. I got Teruna, send me message. Hari, very good. Hari, good. Okay, what's the basic concept? The Vernier caliper has two linear scale. The first one, main scale, it is 150 centimeter length. Sorry, 150 millimeter length or 15 centimeter length. Some amount of particular parts on main scale divide into particular number of identical parts using Vernier scale. That's the basic concept. And the Vernier scale, we can move along the main scale. Make up the move karla measurements ganna pula. We can get measurements using moving this Vernier scale along the main scale. Along the main scale. Okay, that's the basic principle of Vernier caliper. Hi. Balan. It is the and not he. The mistake. The principle of the Vernier scale is based on comparing division on the divisions of the main scale with the divisions of Vernier scale to obtain more accurate measurements. Divisions, some amount of divisions on main scale divide into identical parts, no? In Vernier's instrument, a certain number of divisions on Vernier scale are made. Certain number of divisions on Vernier scale is made equal to different number of division on main scale. Hurry. Because of this small difference in division length, one of the Vernier scale making will exactly coincide. Okay, that you can discuss later. Coincide. By identify this coincide division, we can get the reading. In reading calculation part, I will explain this point. Okay. Come to second topic. The Vernier scale has two main scales. Now you already know. The Vernier caliper has two scales. What is the first one? Main scale. Main scale. The main scale is a fixed scale. No. Yes. The main scale is a fixed one. No? We can move. We can't move. Okay. These are main scale. These are main scale. These are main scale. We can't move. Fixed scale of the instrument. It's usually graduated in millimeters. Yeah. The scale has marked in millimeters. See. Can you see these values? Not clear, right? Clear, Nan. Now, is it clear? Don't think about this screen. This is 0, 10, 20, 30, finally up to 150 millimeters. They scale in millimeters and up to 150 millimeters, so 15 centimeters, and provide main scale reading. Reading part we can discuss later. Go to Vernier scale. The Vernier scale is a movable scale. Now you already know it's a movable one that we can move along the main scale, right? That we can move along the main scale. That sides along the main scale. It is designed to measure fraction of the smallest division of the main scale, allowing more precise, accurate measurements. Come to this point. In a commonly used Vernier scale, mean, actually in our syllabus we discussing about this type, but in industries, different industries use different types of Vernier caliper as well. Okay, I will explain these different types as well. First of all, you need to understand the commonly used, most used, frequently used Vernier caliper, 9 millimeter on main scale, divided into 10 equal segments. 9 millimeter on main scale, divided into 10 equal segments. If you don't have tooth, if you have tooth, you can draw this diagram on this box. If you don't have tooth, students who don't have tooth, please note down this point on your book. Commonly used Vernier caliper, 9 millimeter main scale divided into, 9 millimeter of the main scale is divided into 10 equal divisions on the Vernier scale. Okay, tomorrow you can get tooth. You can check your tooth pack tomorrow in your nearest post office. If it is not received, please let me know. I'll check and I'll check what happened to our tooth packs. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and it is continue up to 150 millimeters. Continue up to 150 millimeters. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you can show that's a common type of Vernier caliper, 9 millimeter on main scale, 9 millimeter on main scale, divided into 10 identical parts. 10 identical parts. Okay, that's the basic and commonly used Vernier caliper. This is the main scale. This is a Vernier scale. Clearly note down this. Clearly note down this. 9 millimeter on main scale divided into 10 identical parts using vernier scale. That's the commonly type of vernier caliper. If you complete, send me message. Hurry. Okay, that's a commonly used, and in our syllabus we mainly discussed about this type vernier calipers, 9 millimeters on main scale divided into 10 identical parts. But different types of, I told different industries use different types of vernier calipers. Some vernier calipers, now it is 9 divided into 10 identical parts. No, that's a common type. 9 divided into 9 millimeter divided into 10 identical parts. Some instruments samahara eva tiyena 19 millimeters divided into 20 identical parts. 19 millimeters divided into 20 identical parts. Some instruments 49 millimeters on main scale divided into 50 identical parts. 50 identical parts. If not 99, 99 millimeters divided into 100 identical parts in vernier scale. Different types instruments as well. Okay, different when increase the number of divisions, actually number of divisions, the least count will be changing. The instrument accuracy and sensitivity is increasing. I will show you now. First of all, I will show you this type different instruments. Different instrument. Now you know. Now you already know what is a common type of instruments. No, 9 millimeter divided into 10 identical parts. The first one you already know. First one you already know. Now this is a common type of vernier caliper, 9 millimeter on main scale divided into 10 identical parts using vernier scale. Okay, now I'll change the setting of this virtual vernier caliper. Now what happened? What happened now? 19 millimeter on main scale divided into 20 identical parts. I got different types of instruments. Different types of instruments. 19 millimeter on main scale divided into 20 identical parts. Okay, I told meter thodaya thiyena. Now what happened? 24 millimeter on main scale divided into 25 identical segments. Identical segment. I got, see, 19 millimeter on main scale divided into 20 identical parts. But this is in our syllabus, we mainly discussed about this one. 9 millimeter divided into 10 identical parts. But you should know different instrument as well in different industries. Clear? Guys, are you clear? That's a very interesting lesson. Now we are discussing very new instrument for you. Very new instrument. That lesson very interesting. Okay, come to next topic. The least count of the vernier caliper. Okay, now you already know our. I told in least count lesson. In least count lesson, do you remember I told the least count of vernier caliper 0.1 millimeter කියලා කිව්වා නේද? 0.1 millimeter. But in mathematically now you can understand what's the meaning of the least count of vernier caliper and how we calculate. In the lesson එක. Okay, the least count of the vernier caliper. Okay, what's the, before calculate, what's the meaning of the least count of the vernier caliper? last week we discussed about least count. That's the smallest minimum measurements possible to take accurately by any instrument. No, any instrument. Now it is especially given vernier caliper. The vernier caliper least count means the smallest minimum measurement of the possible to take accurately by vernier caliper. Hari. Made minimum or least measurements of vernier instrument obtained from the vernier caliper that we called as the least count of the vernier caliper. Okay, to calculate the least count of vernier caliper, we have very simple equation. I'll show you. We have very simple equation to calculate the least count of vernier caliper. Hari, මේ බලන්න හොඳට බලන්න. Try to focus. Okay, this is a common type of vernier scale, right? Hari. තමයි හොඳට බලන්න. To get the least count of vernier caliper, any type of vernier caliper, we have very simple equation. මේ බලන්න. The least count of vernier caliper, equal main scale division. Main scale division size minus vernier scale division. Very simple. Vernier scale division. Main scale division divide by minus vernier scale division. In short form, we can say main scale division MSD minus vernier scale division VSD. In short form, MSD minus VSD is the least count of vernier caliper. Hari. Now I'm going to calculate the least count of above scale. Hari. Api gamu. Okay, tell me what's the meaning of main scale division size? Main scale division mean the gap between these two lines. මෙයාගේ gap එක. One division size. Main scale. What is the size? Kalindu. What is the size of one division on main scale? Very simple. එක part එකක්. One part on main scale. Size. No. One division, Puta. One division. This point to this point. මෙන්න මේ point. Oh, this point to this point. One division. One small division. Yes, it is 1 millimeter because 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One division, 1 millimeter. Clear, Shivan? One division, it's 1 millimeter. Yes, 1 millimeter. 1 millimeter. Minus vernier scale division. Vernier scale division size. Vernier scale division means this point to the gap between two lines. Okay, before get value, tell me it is less than 1 millimeter or more than 1 millimeter. Vernier scale segment. Yeah, 1 millimeter. Yes, definitely it is less than 1 millimeter. Okay. Then how to calculate the segment? How to calculate the length of one segment of vernier scale? Anyone? Can you send me value? One segment value of vernier scale? Very good. Shiva. Others? May size එක කීයද? එක part එකක vernier scale. What's the size? of one segment of vernier scale. Now, Kalindu, I want this point to this point. How to get this? You can say 9 millimeter sector, 9 millimeter segment on the main scale, divide into 10 identical parts. No, then if you want get one part value, no, Temi. Now 9 millimeter divided into 10 identical parts. Ne? Then if you want to get one value measurement, one value size, one segment size, what I need to do? 9 millimeter divided into 10. Now you can, that is a method. Okay, that's a short method. Main scale division, main scale number of parts you can divide by vernier scale number of parts. Then you can get one segment of vernier caliper, vernier scale, one segment size. 1 millimeter minus 9 over 10, what is the size? What's the value? 0.9. 0.9 millimeter. Okay, that's why I told common type of vernier caliper 1 minus 0.9. It is 0.1 millimeter is the 0.1 millimeter is the least count. 0.1 millimeter is the least count. 0.1 millimeter is the least count. Okay, if you have tooth, okay, this measurement already given, but if you want in simple way, you can note down this calculation in this place. If you don't have tooth, please note down this. Please note down this on your written book. Okay, clearly note down this. It's already given, but better to note down. Quickly. Complete. Complete. Done. Okay, what's a very simple equation of the least count of vernier caliper? MSD minus VSD. Main scale division size minus vernier scale division size. Main scale division size minus vernier scale division size. Okay, all take your notebook, take your writing book and write down question number 2. No, question number 1. Question number 1. There is a vernier caliper. There is a vernier caliper 19 millimeter on main scale. There is a vernier caliper 19 millimeter on main scale, divided into 20 identical parts, using vernier caliper. So using vernier scale, 19 millimeter on main scale divided into 20 identical parts using vernier scale. 20 identical parts using vernier scale. Calculate the least count of this instrument. Calculate the least count of this instrument. Okay. Quickly calculate and send me value. Calculate the least count of this instrument. Now 19 divided into 19 millimeters on main scale divided into 20 identical parts. 19 divided into 20 identical parts. 19 divided into 20 parts. Okay, get the least count. Same method, same equation. Now it is like this. 19 millimeters. Yeah, these are 19 millimeters divided into 20 identical parts. Sorry, it is not the 20. 20 identical parts. No need to draw this diagram. You can just calculate the value. That's enough. 20 identical parts. 19 millimeter. Okay. Don't take time. Quickly calculate. Pankara. Very good. Very good. Tumin. Tumin or Netsara. Netsuka. Sorry. Very good. Correct. Others. You can use normal calculator if you can't divide this value. Very good. Hasandu. Correct. Hesandu. Hesandu correct. Khalindu. You have a mistake. Yeah, good. You have very small mistake. You have done correctly, but you have very small mistake. No, Shivan. No. You are wrong. Substitute this equation. The least count is asking the minimum value. Okay. What is the equation? The same equation, right? The main scale division minus vernier scale division. Main scale division minus vernier scale division. MSD minus VSD. MSD minus VSD. Very good. Tarindi. Tarindi correct. Okay, MSD minus VSD main scale division minus vernier scale division. Okay, main scale. How about the one segment of main scale? It is 1 millimeter, same. නේද? යන්නේ 1 millimeter to millimeter. Yes, it is 1 millimeter minus now 19 millimeter divided into 10 identical parts. 19 millimeter divided into 20 identical parts. Now 1 millimeter, 19 over 20, what is the value? 19 divided by 20. 19 divided by 20 means 9.5 divided by 10. It is 0.95. 0.95 millimeter. Now you can get 1 millimeter minus 0.95, it is 0.05. Very good. 4 students correct. 0.05 millimeter. 0.05 millimeter. So, sir, what do I need to? Xenon. Better to go to YouTube. Do you know our YouTube channel? Okay, wait, I will show you. I will send you our link. එතන මේ wait. ආට මිස් වෙච්ච තැන ඉඳන් බලන්න පුළුවන්. Yeah, lot of areas heavy rain. Colombo also going to start raining. It's thundering. Okay. Okay, it is 0.05. Okay, let's note down another one. Question number 2. There is a vernier caliper. There is a vernier caliper. 49 main scale divisions on main scale. 49 main scale division on main scale. 49 main scale divisions on main scale. 49 main scale divisions on main scale divided into 50 identical parts. Divided into 50 identical parts. using Vernier scale. Divide into 50 identical parts using Vernier scale. Calculate the least count of this instrument. Calculate the least count of this instrument. Calculate the least count of this instrument. Okay. Get this value. Get the value. Quickly. We have a lot of things to discuss today. Still, we are discussing least count. Very good, Hezandu, correct. Hezandu, correct. Others? Yes, Tarindi, correct. Okay. Main scale MSD part, main scale 1 division 1 millimeter, VSD, Vernier scale 1 division only changing, right? Now 49 divided into 50. 49 divided into 50, it is 0.98. 0.98. 0.98. Yes, all are correct this side. Very good. 0.98, 1 millimeter minus 0.98, 0.02. 0.02 millimeter. 0.02 millimeter. Hello. Okay. Okay. Now you can find least count of any type of vernier caliper using our basic equation. What is the equation? The least count of vernier caliper equal MSD minus VSD. Main scale division minus vernier scale division. Main scale division minus vernier scale division. MSD minus VSD. Okay. Okay. Now skip this page number 4 and go to page number 5. Go to page number 5. If you don't have tut, no problem. Go to page number 5 in your PDF. Okay. Now we are going to discuss what are the parts of vernier scale and vernier caliper. What are the parts of vernier caliper and what are the functions of them? Hari, what are the functions of them? Okay. First of all, I will explain using our virtual caliper. Then I will show you how to use parts of vernier caliper. Hari. Now you only know two parts. What's the name of this? This is a main scale. The long scale we called as a main scale. Main scale. What is this short one? This is the moving scale is vernier scale, right? Vernier scale. Vernier scale. Vernier scale. Vernier scale. Now you know only two parts. Okay, I will show you all parts. Give me a second. Okay. They are the parts of vernier caliper. Okay, first of all, this is a vernier scale and this is a main scale. This is a main scale that you already know. Okay, now how we can write on this? Okay. I have pen. Give me a second. Hi. Okay, good. Now you can see this is the main scale. This is a main scale, and this is a vernier scale. This is a vernier scale. This is a vernier scale, right? Okay, and okay, this instrument, now you can see there are two jaws here, right? මේවට අපි කියන jaws කියලා. Actually, the purpose of this lower side jaws, the purpose of this lower side jaws to get the external diameter like this, to get external diameter or thickness. Okay, that's actual usage. That's actual usage using vernier to get external diameter, like to get external diameter like this, Okay, therefore these jaws we called as external jaws. What are the name? What is the name? External jaws. Both we called as external jaws. External jaws. මතක තියාගන්න ඕනේ. External jaws. External jaws. Okay, they or outside jaws or external jaws, both correct. Huh? External jaws. External jaws. External jaws or outside jaws, both same. Okay, then what is the purpose of another two jaws? තව දෙකක් තියෙනවා. We have another two jaws. I'm going to this green color surface to show you clearly. Okay, what is the purpose of this another two jaws? That one also we can move. What's the purpose of second above part two jaws? To get internal diameter. Wait, I will show you. Wait. Now this is a bottle lid. Okay. Now I want to get this internal diameter. If you want external diameter, I can get by external jaws. Right? Using external jaws, I can measure by external jaws. External jaws. If I want internal diameter, I can measure by internal jaws. Internal jaws. Internal jaws. Internal jaws. It's fixing. Internal jaws. Okay, the name of above jaws, inside jaws or internal jaws, both same. Internal jaws. Internal jaws. Internal jaws. Internal jaws. Okay, now we discuss three parts: main scale, vernier scale, internal jaws and external jaws. Okay, now you can see there is a strip here. When the vernier scale move into left direction, what happened? It's opening a new probe, no? Or strip. Okay, what's the purpose of that? What's the purpose of this strip or this rod? Anyone? Can you imagine? Can you suggest? What's the purpose of this one? Now, lower side jaws to get external diameter. The above side, the upper jaws to internal diameter. To get internal diameter. Okay, can anyone? What's the purpose of this? Can anyone say? Nanika hitana vidiyata? No problem. If it is wrong, I will explain. Anyone? What's the purpose of it? Making a cart hari aninna. What's the purpose? If it is as a gun, very good. Very good, very good, very good. To measure depth, how to measure depth using this rod? This is a method. This is a method. See, I want to get this depth of this lead. Okay, then I can use this rod and move this part like this. Now this is a rod. This is a depth. Therefore, this rod we called as depth measuring rod or depth measuring rod or depth prop or depth measuring strip කියලා කියනවා. Depth measuring stripped. Both names are correct. Okay, don't worry, both names are correct. Depth prop or depth measuring rod or depth measuring strip, both correct. Strip mean api make up patiyak again, that's why we called as strip or depth measuring rod, just like a rod. Okay, now we know main scale, Vernier scale, internal jaws, external jaws, and depth measuring prop or depth measuring rod or strip or whatever depth measuring tool. Okay, now you can see there is screw here. There is a screw here close to Vernier scale. What's the purpose of that? Can anyone send me what is the purpose of this screw? Above screw. Okay, I'll show you. Practically, I'll show you. To tight, yes. Now I am going to take measurement. Okay. Wait, that's the actual purpose. In order to fix the, yeah, very good. You correct. All are correct. Yeah, the name is screw nut. Very good. Yeah. Now I am going to get the thickness, external thickness of this box. Now I want to remove this instrument, taking this same measurement. Then what I can do, I can fix this screw nut. I can fix and take this out. Then you can see again we can't change the, again we can't move this Vernier, Caliper, Vernier scale or whatever part, again we can't move. Okay, that's the purpose. The fixing is the fixing or tightening is the purpose. Tightening of moving parts. Okay, that's the purpose of the, what's the name of this part? What's the name of this part? Screw nut. Screw nut. Screw nut. Screw nut. Oh, screw clamp or screw nut. All names correct. Eh? Screw nut or screw clamp. Okay, but this instrument not given this wheel. Make wheel එකක් තියෙනවා. This wheel. What's the purpose of this wheel? Can anyone send me? What's the purpose of this wheel? Yeah, very good. To move the sliding jaw. Very good. Shivan, you sending me very technical terms. Very good. To moving the to easy movement of sliding jaw part. Sliding jaw part means this moving part to move, easily moving. Okay, what's the name of this? Shiva. What's the name of this wheel? What's the name of this wheel? That we call sliding wheel. Sliding wheel. It is not given in this diagram. That is sliding wheel. Sliding wheel. Sliding wheel. Sliding mean moving. No? Sliding. It's a it's a similar word. Sliding wheel. Sliding wheel. Okay, they are the all parts of Vernier caliper. They are the all parts of Vernier caliper. Okay. Now again revise one time. Main scale, Vernier scale, external jaws, internal jaws, depth measuring strip, screw nut, and sliding wheel. Sliding wheel. Okay, please check your tooth. Please check your tooth. I have given all parts. Internal jaws, external jaws, sliding jaw I will explain later. Vernier scale, main scale, depth measuring strip. Depth measuring strip. The Y and X given. X is the screw nut. The Y is the sliding wheel. Wheel to move sliding jaw. That's sliding wheel. Okay. Now I am going to show you the part. You have to send me the name. Practice. Just practice. Hurry. Okay, what are the names of this? Hamo. Adam padang karamu. What are the names? Internal jaws. Internal jaws. Next one. Very good. External jaws. What's the name of this? Very good. Depth measuring strip or depth measuring probe. What's the name? Screw nut. Very good. What's this wheel? What's the name of this wheel? Very good. Sliding wheel. Sliding wheel. Nam godak thiyena ekak mata tiyagan. Hari. You can remember one of name. That enough. Yes. Don't think this is make it in. It has a digital screen instead of Vernier scale. That's only difference. It's a modern one. It's a modern one. But in our lesson, we discussing about manual one. Okay. Manual one. The thing, if you know about manual Vernier caliper, you can understand any type of Vernier scale. You can understand any type of Vernier scale. Hi. Now you know what are the parts, they are functions of Vernier caliper. Okay, now can you identify now can you identify some parts of this Vernier caliper is moving, right? Moving, but some parts are fixed. Some parts are fixed. These all moving parts of the Vernier caliper we called as in a one name, that we called as sliding jaw. All these moving parts we called as sliding jaw, and all fixed parts we called as fixed jaw. This is my right hand, this is my left hand. Now my right hand is fixed. It's fixed now. It's fixed, and left hand is moving. Left hand is moving. Then my left hand parts are the sliding jaw. Left hand parts are the sliding jaw. Right hand sides are the fixed jaw. I got the difference sliding jaw and fixed jaw. Make it any movable jaw here. The same thing, sliding jaw. It's another similar name. Sliding jaw kilat kiyane meyatam tama. Sliding jaw. Sliding jaw. I got understood. Do you have any doubt? Do you have any doubt? Up to now? Say no. Hurry. Now, okay, can you write down, can you note down what are the movable parts and what are the fixed part? Quickly note down. If you don't have tute, please note down in your book. Note එක තියෙනවා මෙතන ලියමු. Okay, the first one, what are the movable parts and what are the sliding jaw parts? The first one, one external jaw. One external jaw. External jaw is a sliding, right? One internal jaw. One internal jaw. I'm writing short way. Third one, what else? Vernier scale, very good. Vernier scale. Vernier scale is sliding. Vernier scale. Fourth one. Is that all? What else? Depth measuring probe. Depth measuring strip. Depth measuring strip. It's moving. What else? Tamanad. What else? What else? Sliding jaw parts. Yeah, very good. This nut. Yeah, nut also moving, right? Screw nut. Screw nut. There is another one. තව එකක් තියෙනවා. But wheel. Sliding wheel. Sliding wheel. Sliding wheel. Sliding wheel. Okay, what are the fixed jaw parts? One external jaw. One external jaw, one internal jaw, and main scale not moving. Main scale not moving. Main scale not moving. Main scale one internal jaw and one external jaw. Complete up to now. Please quickly send me message. Complete up to now and understood. Today before complete class, I will improve you how to read any measurement using vernier caliper. To read measurement using vernier caliper. Okay, now I have explained practically what are the purpose of main scale, vernier scale, everything. You can read them, and if you have any doubt, you can ask. Okay, up to this level we completed. Now I skip one part in page number 4, right? I skip one part in page number 4. Go to this page. Okay, taking measurements using vernier caliper and vernier scale, main scale and vernier scale. Now I will explain in our board step by step very clearly how to read and how to take any measurements using vernier caliper. Okay, first of all, I will show you how to get measurement using vernier caliper. How to get measurement using vernier caliper. Hi. Now this is a vernier caliper, right? Now it is a vernier caliper. Now, if I want to get external diameter, I can place an object between this external jaws and tight this object. Actually, not over tightening. Make up a without over tightening. We have to tight by using this sliding jaw. Okay, think. Wait. Okay. Okay. Okay, think this is the object. This is the object now between I have placed between external jaws. External jaws. Now I can read using vernier scale and main scale this reading. That's the method. If I want to get internal reading, I can place object between internal jaws and take measurement using internal and external jaws. If I want depth reading, we can use depth measuring strip to get depth measuring readings. Now I will show you how to read this type. If you got any external reading or internal diameter reading or depth measuring reading, how we can read using this main scale and vernier scale. Okay, can we get another 15 minutes to complete this part? එතකොට ඔයාලට read කරන්නත් පුළුවන් within first day. No issue, right? Not tired, ne? Today we discussed very interesting part. Only 15 minutes. 15 minutes. I'll finish class now 37 50 8:50 I can complete. Remember that it is very simple. It's very simple. Okay, think when I take any external diameter or internal diameter, the main scale and vernier scale positions like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it is continue level 12, 13, 14, 15. It is continue up to 150 millimeters. And this is a vernier scale. This is a vernier scale. Okay, this is a vernier scale now. Due to this reading, due to this measurement, the vernier scale shift to right side. That's normal. The vernier scale shift to right side. When if I take reading, if I got any diameter, I'm going to get the thickness of my finger. Then what happened? The vernier scale shift to right side. Okay, now this is the position of vernier scale 0. This is the position of vernier scale 0. Okay, now I'm going to explain how to read this measurement. How to read this measurement. It is very simple. I will explain this method into classified into 4 steps. Then when you practicing, you can as look in this reading, you can get the measurement. Okay, no need steps. Hurry. First of all, you can practice with these my steps. Hurry. Please go with my steps. First one, the first step, get main scale reading. Main scale reading. Get main scale reading. Hurry. For this measurement, how to get the main scale reading? Always main scale reading is the reading on main scale before Vernier scale 0. Now this is the position of the Vernier scale 0. 0, 1, 2 millimeter is the main scale reading. I got 2 millimeter is the main scale reading. 2 millimeter is the main scale reading. The second step, get Vernier scale coincide parts. What's the meaning of coincide parts? Coincide parts. What's the meaning of coincide parts? Can anyone send me what's the meaning of coincide parts? Coincide parts. Coincide parts mean like this. In Vernier scale now, okay? The main scale part is completed. First step, main scale part completed. Vernier scale, 0 not coincide, 1 not coincide, 2 not coincide, 3 is Vernier scale, 0 not coincide, 1 not coincide, 2 not, 3 not. But what happened to 4? 4 is coincide with main scale value, right? 4 is coincide. Therefore, what is the coincide number? 4. Main Vernier scale coincide number. Vernier scale coincide number 4. Then, third step, coincide number, that means previous part answer, coincide number multiplied by least count of the instrument. You know, if it is 10 Vernier scale parts, always least count is 0.1. If it is 10 Vernier scale segments, it is 0.1. Then 4 multiplied by 0.1, the value 0.4, right? 0.4. 0.4 is the value. 0.4 is the value. 0.1. 0.4 is the value. Now, finally, final step, how we can get the reading, main scale value, main scale reading, add into third part answer, that means third step answer, that means 0.4 add karam hari. Add coincide. Oh, I write in third part answer, third step answer. Okay, now first step, main scale value 2 millimeter plus third step I got 0.4 millimeter. Then the reading is 2.4 millimeter. Understood? Understood? Okay, I will explain what are the steps again. First, get the main scale reading. What's the main scale reading? Always the main scale value before start Vernier scale 0. Before meet Vernier scale 0. Next, in Vernier scale, get the coincide part. Coincide part. Ek part එක coincide වෙලා තියෙනවා main scale එකත් එක්ක. This part number. Then this number multiplied by least count of the instrument. Okay, this third part multiplied value and main scale value add. This is the final answer. Understood? Tirna? Sinon? Hari. Okay. Take your notebook and draw this scale and write down steps. This is steps given in the tute as well, but better to write down. Better to write down this calculation. So only for first one. From second one, you don't need these steps. Only for you understand. Or can you write down it in 1 minute? Bundle. Complete. Khalidu. Narindi. Complete. Good. Okay. Now can you get the measurement using these steps? Please try to get this ready. Try to get this ready. Okay. Can you send me what's the reading given in the figure? Okay, now you can use steps. Get the main scale value, get the coincide number, then multiply coincide number with least count, then add these two values. No need to write down steps. I need only calculation, only value. Okay, what's the reading? What's the reading? What's the reading? You can send me. Very good. Then on. Good. You have to mention unit as well. Unit එක තියෙන්න ඕනේ. If not, actually it's wrong. Yes. Kalindu? Yes, Anand? Okay, what's the method? No need step, note down steps now. Others? ගත්තේ නැද්ද? Tarindi? No, small mistake, Shiva. Okay, first step, get the main scale reading. 0, 1, 2, 3, 4. 4 millimeter. 4 millimeter. 4 millimeter. Next step, get the coincide number. 0, 1, 2, 3, 4. 5 is the coincide number, Shiva. Not 4. 5 name. 4 is not coincide. 5 is the coincide number. Now 5 multiplied by least count. If it is 10 Vernier parts, 0.1. 5 into 0.1, it is 0.5. Now 4 plus 0.5, 4.5 millimeter. I clear. If anyone can't understand, please send me. If anyone can't understand these steps, any step, any point, please ask me now. Because now we are going to discuss a lot of questions. I will give you scale, you have to send me answer. We have another 5 minutes. Poddai tiyenta. Five. As coincide part. Yes, Andu. Coincide part always 0, 1 not coincide, 2 not coincide, 3 not coincide, 4 not coincide. This is the fourth one. 4 not coincide. Fifth one is a coincide one. Coincide it just become a one line with main scale. Practice karam, let's practice. Yeah. Practice. You can't buy hard this. Actually, this lesson you can practice only. I will give you scale. You have to send me answer. This one. Quickly. Oh, sorry. Sorry. Okay, I'll help you for first run. Okay, what is the main scale value first? What's the main scale value now? Okay, send me one by one. What's the main scale value? Hey Sandhu, what's the main scale value for this one? No, Puta. No. xenon. This is a Vernier scale 0. This is a Vernier scale 0. Not this line. Don't misunderstand. Yes, Putta. Okay, 1 centimeters means see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 centimeter means 10 millimeter. 11 millimeter is the main scale value. 11 millimeter. 11 millimeter is the main scale value. And how about the coincide part now? Coincide part approximately 7. Nee? Approximately 7. And total 10. Total 10. Then 7 multiplied by 0.1. It is 11.7. 11.7. Don't think about 11.7. Okay, this one. Simple one. You can send me answer. Don't take this line, okay? This is a edge line of the Vernier scale. This is a 0. Make a හැමෝටම පුළුවන්. Okay, first send me what is the main scale value. Hey Sandhu. Palindu. Good Putta. No 7. Check again. No Kalindu. Main scale reading I want. Try to understand. I balan. First of all, you have to understand the steps. First of all. Okay, what's your first step? Get the main scale reading. Main scale reading, the first value is 0, 1, 2, 3. Oh, sorry. As main scale reading, you have to read the value on the main scale before Vernier scale 0. This is a Vernier scale 0. The before value, it is 0, 1, 2, 3. 3 millimeter is the main scale value. Khalid. Yes, Shavin correct. 3 millimeter is the main scale value. 3 millimeter is the main scale value. Next, get the coincide number. 0, 1 not coincide, 2 not, 3 not, 4 not, 5 coincide. Now 5 multiplied by least count 0.5, 5 into 0.1, 0.5 millimeter. At this 2 value, 3.5 millimeter is a very Khalindu, understood? Go step by steps, okay? Step by step, yeah. Make practice within 1 second you can get the answer. Don't worry. Now get step by step. Step by steps. Okay, this one. Careful about main scale. It is 40. 40 mean 40 millimeters. 40 millimeters. $40 millimeters. Okay, send me only main scale reading. Hasandu, correct, but small decimal point mistake. Balan. Yeah, 44 millimeter is a, yeah. See, 40, 41. 40, 41, 42, 43, 44. Very good. 44. This is the main scale reading. 44 millimeter. Very good. Now, Kalind, 44. May are 40, 41, 42, 43, 44. Okay. Now, 44 millimeter is the main scale reading. 44 millimeter. Next, coincide parts. 0, not coincide. 1, not 2, not 3, not 4, not 5, not. But 6 coincide perfect, no? 6 perfectly coincide. 6 perfectly coincide. 6. Now 0 0.6. 6 means 0 0.6 millimeter. Now add these two values. 44.6 millimeter. Kalindu, try to follow step by step. Hesandu, coincide is not 5, no? 6 nail. ඒක දැක් නැද්ද? හරි. Okay, final one. Final one. Can you read this reading? හරි. ඉක්මනට දාන්න. We don't have time today. Because in physical class we discussed up to this level. That's why I am doing. Otherwise, it will be a problem. What is this reading? Very good, Shivan. Very good. Others, quickly send this value. Very good, Kalindu. Now correct. And now you are in the track. Very good, Hasandu. Very good. Sinon, very good, very good. Then හැමෝම හරි. පොඩි වෙලාවක් යනවානේ. හරි, කමන්නේ. Okay. Main scale reading 0, 1, 2, 3 is the main scale reading. The coincide part 4, then 3.4 because 4 into 0 0.1, 0 0.4, 3.4. Good. Very, very good. Hari, final value. Final one. Read this measurement. Shivan correct. Others? Hasandu correct. Very good. Senon correct. Good. Halindu. Very good. Yes, all are correct. Okay. As I promised earlier, now you can read any measurement using vernier calipers. No? Okay, next week. Okay, today I got 20 minutes additional time for because in physical class, actually, our two physical classes, we discussed up to this point, up to this reading taking. If it is unbalanced, it is very difficult to continue. Unbalanced tsunami, it will be difficult. Okay, that's why I got additional time. Okay, next week I'll try to complete within before 9 p.m. Now 9:05. Okay, do you have any doubt today class? Today we discussed very interesting and important part. Next week I will give you more exercise of reading measurements and start errors of zero error. Errors of vernier caliper. Zero errors of vernier caliper. It's a new section. Okay. Are you satisfied? Are you, do you have any doubt? Any part? Okay, then let's meet next Sunday 6:30 p.m. with zero errors of vernier caliper. Goodbye. Practice this again one time in homework. Okay, goodbye. Good night.